We're going to go on and get started today. We're finishing up the note sheet from yesterday. So yesterday we talked about addition, subtraction, and multiplication. Today we're going to be talking about division, and then we'll go over some other ways that we can do this using the calculator. So when we talk about f divided by g of x, well, this is the same as f of x over g of x. F of x divided by g of x. Now this is going to go similar to what we did with our multiplication. This is going to be a little bit different because we're dividing, not multiplying. Well, f of x is 6x, so we can replace f of x with 6x. G of x is x to the 3/4. So we can write that in there. Any questions on any of this so far? Yes. The main reason we don't do that is because it wants us to find f divided by g of x. It wants us to state it in terms of x first, then plug it in. Now, if it had, we'll get back to this problem here in a minute. So here, again, it's just talking about that. Actually, that's the same problem. So this one here, we could do that. Because looking at this here, it says this is f of x, this is g of x. And we can use a graphing calculator to evaluate f of x, f plus g of x, f minus g of x, f times g of x, and f divided by g of x when x is equal to 2. So we would do it with this one because it's not asking for each one of those functions individually. It's just wanting to know what is their values at 2. So if it's doing that, we can just plug it in. But here, since it wants us to find out what it is, we have to do that first. Okay. Now, because the only thing on top, well, we do have variables on top and bottom that are the same. And then whenever we have, like, bases, we subtract the exponents. And the exponent on top always goes first, so we have 1 minus 3/4. Well, 1 minus 3/4 would be what? One-fourth. It would be 1/4. Because when we do 1 minus 3/4, we need the bases to be the same. So we would change 1 into 4/4. And then our 4 minus 3 would give us 1. Yes. So for us here, f divided by g of x is 6 times x to the 1/4. Huh? No. Okay. Now we need to look at the domain of this function. So it's going to be what? Why not equal to? Right, because we're talking about division. In our original equation, we had g of x in the denominator. We can't have it equal to 0. So we still talk about the original function. So most of the ones on this here is going to be greater than 0. We cannot have a 0 in the denominator, even though our final expression doesn't have a denominator, it still cannot be 0. And last but not least, we need to find out what it is when x is equal to 16. So we'd have f divided by g of 16, which would be 6 times 16 to the 1/4. And again, at this point here, I would just type this into the calculator, because we can do it by hand. 16 to the 1/4 is 2, and 16 times 2 would give us 12. And 6 times 16 to the 1/4 will still give us 12. Yes.
I need to go back over how you look at
Okay. Yes. And we have some multiplication here coming up again. All right. Bless you. Let f of x be 4x and g of x be x to the 2/3. Find f divided by g of x and state to the domain. Then evaluate the quotient when x is equal to 27. So again, what we're doing is f divided by g of x. Well, this is the same as f of x divided by g of x. Now in this case, f of x is, and g of x is, x to the 2/3. Okay. Now, because x and x to the 2/3, the bases are the same, we can subtract the exponents. So that would give us 4x to the 1 minus 2/3. Now, what is 1 minus 2/3? It would be 1/3. So 4x to the 1/3. Yep, that's what I thought. So, our f divided by g of x is equal to 4x to the 1/3. Okay. Any questions on how we got to this point so far? Okay. Now this one here is a little bit different than what we've been dealing with so far. Because cubed roots, because 1/3 is a cubed root, 2/3 is a cubed root. I can take the odd root of a negative number. Because negative 8 cubed is negative 2. We can take the odd root of a negative number. So that means I can have all real numbers for a cubed root, because we can have positive or negative. So this here is all real numbers yes. Since we have x by itself in the denominator, it can't be 0. Because again, 2 times 2 is 4. 2 times 2 is 6. 6 times 2 is 24. 24 times 2 is 36. 36 times 2 is 96. 96 times 2 is 128. 128 times 2 is 240. 240 times 2 is 440. 440 times 2 is 6. 6 times 2 is 8. Yes. Since we have x by itself in the denominator, it can't be 0. Because again, f divided by g of x is f of x over g of x, but g of x cannot equal 0. We cannot divide by 0. So we have to include this exception. Now, another way we can really write this is that we can say x is an element of the real numbers sub pretty much excluding 0. The domain x is an element of the real numbers except 0, except for these here. So it's another way to write it. Of 27. And last but not least, we need to plug 27 in. We need to see what is f divided by g of 27. Should be 4 times 27 to the 1/3. Yes, because the cubed root of 27 is? Yeah. Yeah, because 3 times 3 is 9. 9 times 3 would be 27. So we would get 4 times 3, which is 12. So on addition, subtraction, multiplication, or division, if we have an odd root, cubed roots, fifth roots, and so on, the domain is all real numbers. Except when we're talking about division, we do have to find the restrictions on it. Any questions on this here? Any questions on any of this so far? Okay. So we're going to look at this here. So this one here, we're going back to addition and subtraction. We have one of these here. We'll go back over those, then multiplication and division, and then we'll look at how the calculator can do this. Let f of x be negative 2 times x to the 2/3, and g of x be 7 times x to the 2/3. Find f plus g of x and f minus g of x, state the domain of each, then evaluate for when x is equal to 8. So f plus g of x. As we said, this is f of x plus g of x, as we're adding those two functions together. Now, f of x is negative 2x to the 2/3, plus g of x is 7x to the 2/3. Yes, and this would be 5x to the 2/3. So since both of the variables are the same, x to the 2/3 and x to the 2/3, we can add the coefficients, the numbers in front, and get this here. What would the domain be? Because it would be if it was talking about an even root. Is it an even root? It's all real numbers. Because we have an odd root, we can have any number. Because we can take the odd root of a negative number, and it's just fine. So this here is all real numbers. So our f plus g of x that we found was 5 times x to the 2/3. Okay. Switch over. Now we also need to find f minus g of x, which is our f of x minus g of x. All right. So just like with addition, we'll replace f of x with negative x to the 2/3. We'll replace g of x with 7x to the 2/3. And with our subtraction, we get negative 2x to the 2/3 minus 7x to the 2/3, which would give us negative 9x to the 2/3. Questions on this here? for this here. So it's what we're trying to find is what values of x can we plug into the function. Now with most linear functions, polynomial functions, there's nothing that restricts us. But when we look at this here, so x to the 2/3, is there any value of x that I can't plug in? Well, with cubed roots, we can plug in negative numbers, we can plug in positive numbers, we can plug everything in. So we're fine. Now when we talk about square roots, even roots, well, I can't take the even root of a negative number. It just doesn't work. We get imaginary. So that's kind of our restrictions. So that restricts what our domain can be. It has to be positive numbers. So we're trying to see what values of x would still make the numbers inside the root be positive, which we can take it. So that's what we're finding. Now it's also with our radical functions when we divide, because the denominator, the bottom of the fraction cannot be 0, because if it's 0, we're dividing by 0 and that doesn't work. So any value of x, any part of the domain that would make the denominator 0 has to be excluded. We have to take it out. So that's really what it is. It's seeing what values of x don't work. Helps us define what does work. And because of this here, cubed root, everything works. It's all real numbers. So it's an odd way of looking at it. It's almost, for the domain, we look at what doesn't work, and once we exclude all that, then we know what does. It's an odd way to look at it. What was our number? 8. So now we're going to, I'm going to move this down here so we have both of them on the same screen. We just need to plug 8 into each one. So we can start off with f plus g of 8, which for us here, we're going to plug 8 in for x, which would give us 5 times 8 to the 2/3. Now again, at this point here, you can plug this straight into the calculator. 5 parentheses 8, close parentheses to the 2/3. Right, because we could do it with the original one, because that's perfectly fine. Because if we did it with the starting one, because we could look at -2 times 8 to the 2/3 plus 7 times 8 to the 2/3 in the original one here. Well, 8 to the 2/3 would be 4. 7 times 4. Well, -2 times 4 is -8. 7 times 4 is 28. And -8 plus 28 is 20. Okay. Now, if we look at this here, well, 8 to the 2/3 is 4. And 5 times 4 is 20. So it'll give us the exact same thing. We could plug it in the original one, or we can plug it into the simplified version where we actually combine the functions. So either one of them will give us the same answer. It's just depending on which one we want to use. Yes.
I thought it would be cube, right? I thought you'd divide it by.
So the cubed root would be a number times itself 3 times, which would be 2. So the cubed root of 8 is 2, and 2 squared is 4. Mm-hmm. Yes. So for our addition, we would get 20, and for our subtraction, we would get -36. Questions on this here? All right. We're going to do this here with our multiplication division. Then we're going to look at one more, and then we are done for this week. Well, f times g of x is the same as f of x times g of x. Well, in our case here, f of x is 3x. And g of x is x to the 1/5. Any questions on this so far? Now, because x and x to the 1/5 have like bases, we can add the exponents. So it'd be 1 plus 1/5. And what is 1 plus 1/5? What? So we would need to, so we're adding a whole 1 to it, yes? So that would be 5/5. So 1 plus 5 is, so it'd be 6/5. Improper fractions. And the calculators will do that for you pretty easily. 1 plus 1/5. It will either give you 1 and 1/5, or you can convert it to improper fractions. This here, if you see this on the calculator, for the graphing calculator, it's alpha y equals, and it's normally the last one on the list. Second to last on the list, that there, or on the yellow calculator, it does have the same thing. Yep, that's it. And sometimes they have it flipped, n over d, the double arrows u, n over d. And what it's just saying, it's switching between those two forms. But we get this here. Now the domain is going to be all real numbers, because we have an odd root. Because the 5 on bottom of the fraction says I'm taking a 5th root. A 5th root is an odd root. So it's all real numbers. We can take the odd root of any number. Okay. Now looking at our division, this is the same as f of x over g of x, which would be 3x over x to the 1/5. Now, because since we have x in the numerator and denominator, since they are like bases, we can subtract the exponents, which would be 1 minus 1/5. Yes, 4/5. If we're minusing, we're 1/5 less than a whole, and it would be 4/5. Any questions on these here? I know we went a little bit faster than the ones we did previously. Now the domain for this here would be what? Yes? Except 0. All real numbers except 0. Because we still need to consider x to the 1/5 in the denominator, so we have to exclude 0. Any questions on these here? Well, last but not least, we're plugging in 32. We'd have f times g of 32, which is 3 times, no, I was about to write x, it'd be 3 times 32 to the 6 fifths, which would be 3 times 64. Yes. I agree with 192. And last but not least, f divided by g of 32 would be 3 times 32 to the 4 fifths. 4 fifths would be 16, because the fifth root of 32 is 2, and 2 to the 4th would be 16.
You know, I proved I did this, but I changed to see what we did. Where is it at? Yeah, I did it properly. That one. But I had it the first time. I had 48. Let me change. I'm so upset.
Any questions on any of this here? Okay, performing these functions in a graphing calculator. Okay, so to do this here, you're going to need the graphing calculator. I have one right here. So the way that we can do this in the graphing calculator is this. The first thing we're going to need is the y equals. So we're going to go into y equals. Now, f of x is second square root of x. Second square root of x. And that's what we're going to put as y1. So we're going to set y1 as f of x. So in y1, we'll have the square root of x. Yep. And then we'll go down to y2. Well, g of x is what? The square root of 9 minus x squared. We're going to go second square root 9 minus x squared. So we want to set that as y1 and y2. Any questions on this here? Okay. At this point here, we're going to go second quit. So you should be back at the home screen where you can type stuff in, do calculations, yes? Okay. Now what's interesting about these calculators, if we go alpha trace, alpha F4, it should give us this little menu here, yes? So we have y1, y2, all the way down to y0. But I'm going to hit enter. y1. Parentheses 2, close parentheses. Because we're wanting to evaluate this when x is 2, yes? What this is telling the graphing calculator is that I want you to take the function we plugged in for y1, the square root of x, and plug 2 in for x. So if we were to hit enter, don't hit enter, it would tell us what the square root of 2 is. What we're going to do is plus alpha trace, and I want to go down one to y2 and hit enter. So y'all have something like this here so far? Yes? Yes. Let's do the same thing because we're plugging 2 into this one as well. And we should have something like this here. It's really what we said for this here is, well, y1 is our f of x. So we have f of 2 plus g of 2.
Well, this is the same as saying f plus g of
2, yes? So if I want to evaluate f plus g of 2, or f of 2 plus g of 2, we can do this. Now to finish this up, we just need to hit enter. So this here is 3.65 going on out. Questions on this here? Now at this point here, if I want to go and do subtraction of these two, it's actually not that bad. Because if I want to subtract these two functions, what I would do is I would go up and highlight it and hit enter. I would go up, highlight the y1 plus y2. Yep. Or we can recall it again. So, enter. And then we do parentheses 2 minus alpha f4 y2. And what I can do is if I selected this back, I can go over where the plus is and change it to minus and hit enter. So if we subtracted the two, this is what we would get. Okay. Well, it also wants us to do multiplication and division. So I come up, select it. Change it to multiplication. And last but not least, f plus g of x, f minus g of x, f times g of x, and f divided by g of x. All four are right here. Questions on this here? Are we good with this here? Okay. What I'm going to show you this here is, I'm going to say 3x, clear, x to the, yeah, no. Now you should notice these here, these are the ones we did on the previous problem, yes? So, quit. I'm going to have to type this back in because it was clear. Alpha trace y1 of 32 times alpha trace y2 of 32. Now when we multiplied those two functions together for 32, we got what? 192 for the previous problem when we multiplied them together. Calculator tells us it's 192. Went too far. And we divided, we got 48. Yes? So for calculating the values, these calculators can do it for us. That's it. That's all we have for today. Now, doing f of x plus g of x and f of x minus g of x, you're going to actually have to do those out by hand because it has to have a value for x.